So what we're looking at here is the solder side of the voltage graph, and here we have the other side, the silk layer side. You can see there's only a few components to solder on here, so it's quite a quick kit to build. So what I thought I'd do is just go very quickly through the whole process what I did, so you can see how easy it is to do. I'm not going to go through every single solder joint, but I'll go through the most of them, so you can see how quick it is to build this. So first of all, I just placed it into this helping hands, and then you notice I've got some surgeon's gloves on there. And the reason I'm doing that is I've got a sore cut on my hand, and what you don't want to do is get a flux in any open wounds or anything in your hands. It's quite it's not a good idea. Also, I'm using a fan, and I've got a mask on, although you can't see. I actually have a mask on to protect myself from the fumes, so I always wear a mask when I solder up. If I'm doing a lot of soldering, I'll wear a mask. If I'm just doing the odd soldering, I might not always wear a mask. But here you can see I'm placing in all the resistors. There's 8 resistors to insert all together in this kit. So what I generally do is more or less put all of the components in and then turn it over and solder them. But I've done this in stages. I've done. If you start sticking in too many components, it gets a bit awkward. So you end up with loads of wires. As you'll see, when you turn it over, you end up with this rat's nest of wires. So sometimes it's probably best just to put only a few in at a time. So in this case, I've done 4 resistors, then I've done another 4 resistors. So all 8 resistors now are in, but they haven't been soldered yet. I'm just placing in the LEDs. Now the thing is, when you place in the LEDs, make sure that you get them round the right way. That's important. So you want to make sure that you get those LEDs in round the right way, cathode and anode. And that's clear on the instructions for the kit. And here, this is the only IC unit. This contains the 4 op amps inside that, the LM339 I think it is. That includes all the op amps in there. And you can see a little trick here. I use a sort of screwdriver there sometimes when they're a bit awkward to get in. Just get one side in and just gradually bend the other side and go in quite easily. There's another cool trick. I mean, I think this is really what blue tack was invented for, really. It's just great for that. So then, actually I've probably got too many components in to start soldering them out. It's not always a good idea. It's just that I've been a bit lazy here. But I would suggest that you only do a few components at a time instead of trying to solder them all in one go like I'm doing here. But I was being lazy and I just decided to do them all. The problem with doing them all like this, you see I had to bend all the wires quite back. Now that actually makes it quite awkward if you're not so good at soldering. I mean, I've been soldering for quite a while, and so I just didn't worry about it. But if if you're a bit nervous about soldering, then I would only do a few components at a time. In that way, you can stand the wires up more parallel, so they're sort of right angles to the board. You don't really want to be soldering with the wires like I have them there all squashed down. But I did it. But it's better really to use some blue tack on the other side, like I did with the IC on the resistors, really, and then you can have nice straight leads, and they're easier to solder that way. But I bent them all down and soldered them in this example. So here, for example, with the IC, obviously those leads are not bent; they're coming straight out of the board. That makes it much easier to solder. So you can see, I mean, I'm just soldering those in a few seconds. So with the LEDs, I mean, you could do the same thing with the resistant LEDs. You could have done the same thing. You could have had very short leads and put blue tack on the back of them, and it would have made it really easy to solder then. So that's the finished board. But basically, what you'll notice here, I've got the red LEDs on the board, but actually in the kit that I actually build into the tin can, I don't actually solder the LEDs onto the board. You can solder them onto the board if you want, but if you're going to put this in a tin, to use as a display, then you really want to be putting the LEDs into a tin, onto the side of the tin. So in the next few sections you'll see that I've actually not put the LEDs, I've not soldered them directly onto the board. I've actually implemented them so that they stick out the side of a tin. So you'll see that in a little while. But anyway, that's that board. Now here we get on to how we're going to put that inside a tin now. So there's the empty tin to begin with. I've already insulated it with black tape. Now also I'm going to use some perf board. Now these bits of perf board don't come with the kit, so you'll have to get your own bit of perf board. And the potentiometer here, I'll provide that with the kit, but again, if you're going to use that, you're going to need some perf board or something to put that on. What I've done here is I've put that into a perf board. I've cut the perf board so that it fits within the side of the tin there, and the idea is that potentiometer is going to stick out of the bottom of the tin, so I'm going to make a hole in the tin for that potentiometer. Now the wire I'm going to use to wire everything up is 30 AWG Keenar wire. Now that wire there is actually very thin. It's ideal for this kind of work. You see on the circuit there I'm using, I didn't use any headers. Now you could have used headers, but what I've done is I've used coloured leads. The reason I use coloured leads is I like to colour code everything because it makes it easier. So it's so easy to make a mistake and solder to the wrong lead. So if you have your own colour coding and then write it down on a piece of paper, then there's far less chance you'll solder. I mean, there's nothing worse than soldering them up wrong, because sometimes it's very hard to get the solder back off again. So what I do is I use coloured leads. But if you're going to use headers, another trick if you're just going to use headers instead, then you could just put a very small sort of thin cut of plastic coating and then drop that down on one of the headers or on each of the headers so they have different colours. Bit fiddly, but it's much better to make sure you know which leads go to which headers. So what I've done here is I've just been lazy and I've used leads. So, but the only problem with using leads like I've done there is, let me just go back and show you. The problem with using these leads here is that if you get them hot on the other side, if you leave the soldering iron too long on the other side when you're actually soldering up the leads, you can make the lead so hot that it actually starts to melt the solder on the other side. So you have to be careful with that. So anyway, those are those. So you can see it all fits in the tin really easy. Actually, there's some actual some standoffs that also will go in the tin as well, which I'll show you a bit later on. Now to make the markings for the LEDs, you can see I've placed all the LEDs in there now, and what I did was I borrowed the tops of the LEDs, and then when I was able to press it in like I'm doing now, actually made a black mark on that masking tape, and then I got a pen and I just squared in those marks. So that means by doing this you can absolutely get them exactly in the right place. So the way to do that is to actually, if I go back a little bit, if you actually mark the tops, if you mark the tops of these LEDs here with some with an ink pen or something that's the ink's quite runny, then you can just push that into the lid of the tin there and make a mark on that mask. You only need to make it a bit of an ink mark, then you can take it off and draw those square lines over your marks. That'll mean you'll get the holes in exactly the right place. So you want to put the LEDs into the perf board first and then ink them up and then make the marks. So that's really what I wanted to show you there. So there's the marks ready to be drilled. So I actually drill those out now, and then when they're drilled out, you get this finished tin here basically. So this is more or less finished now. It's all the sides have been drilled for the potentiometer there. So I drilled a space for the potentiometer, and I've drilled the 4 holes for the LEDs there, you can see. So that's really now ready for the actual PCB board with all the components to go in there now. So that's the last step. So we're going to place the PCB board inside the tin, and then we'll start, and then we can solder that all up, and it's ready then for the headers and everything. So really what's going to happen inside this tin, we're going to put some standoffs, the PCB board, drill the holes from the marks we've made, and then it's basically finished.
So here we have the finished voltage graph in its tin, and just a quick test on it. We've got the batteries plugged in here, so once it's in the tin, what you want to do is make sure it's still working. So yeah, okay, so that's telling us that that's below 3 volts, I think that is, yes, 3 volts, and this one here is under 6 volts but over 3 volts. So what you might want to do is make sure you always use a 9-volt battery. Really, I haven't got a 9-volt battery in here, but you want a battery that's going to be higher than the cells that you're testing, because this circuit will only give you a measurement on the lights here from the comparison of the voltage you're checking to the one that you're using to drive this. So a better version might be to actually include a regulator, or plug this into something that's fixed at 9 volts, for example. So you could, or maybe even fixed at say 7 volts, and you could use a 9-volt battery and then put it through a regulator, so it regulates it, say at 7 volts or something. So then you know you've got a fixed voltage. Then if you wanted to label these LEDs, you could do, because then it would be quite accurate. Because the battery obviously will go, these batteries here will go flat after a while, that's going to give you the wrong readings, because obviously if this battery gets the voltage on these rechargeables drops below the voltage on the one you're checking, then it'll show all the lights will appear, which is not what you want. But for this kind of simple little thing, as long as you remember to keep a reasonably charged 9-volt battery, it's accurate enough. I mean, you're going to be able to check your 3-volt any items that's specified at 3 volts. You'll be able to get it roughly around there. So that's really, a lot of the time, that's all you need, just get a rough idea that things are working. So it's great for that, simple little rough checks. So if I just take these bands off and then show you what we did to the inside. So undo this battery again. I like to use the connector. You can use the same battery on different applications, so that's quite useful to be able to have this on there. Of course, when you get the kit, you'll be getting one of these. So this is the larger tin. So of course you could quite easily adapt this circuit, maybe use the regulator circuit that I've got and place this all in the same tin, and then you can have, if you really wanted to make sure that these are always showing the same value all the time, you could just use a little regulator in there. So that's the tin you'll get. That means you could put your 9-volt battery in there and have everything in there without the clip, but I just prefer to do it like this, and it means you can get that in a really small tin. It's easy to, it's much easier to store a load of these small kits than it is these, because these are much bigger. But it's easier to get these kits inside these tins, obviously. It's a lot easier because there's more room to play with. The other thing I'll do now is just show you the inside, the finish of this at the inside. So you can see we put our board there with the LEDs stuck inside there. So all the LEDs there were attached to this bit of perf board there. Very simple. And then we drilled all the holes so that give us the LED showing through the bottom of the tin there. The other thing that's useful is for mechanical strength within the box. I use these. Now these really, these standoffs here are really designed to go into PCB boards, but what you can do, which is quite nice, these are really good. You can screw the leads into here, and you can actually screw them down quite tight. And then instead of putting these in a PC board, I stick them upside down so they're in the tin. Just show you on here. There's 2 in there, you can see. So what you actually do is you place them in there like this. As you can see, if you place them in there, and then I just glue the. Once the cables are in, of course, you can then just put some glue on the bottom and the back, put it on there, wait for it to dry, and then you've got a really strong standoff. So that's a really nice little way of doing it. Nice and small, doesn't take up a lot of room, and it's better than putting them on the board. So if you've got them here, then any tension on the leads that you pull, so there's, if you do manage to pull these leads, then the only thing it's going to pull against are these standoffs which are glued to the tin. So much stronger than actually going directly to the board. So I've done that with all of them, and then all you do is just solder up your leads to these standoffs and the standoffs to these out leads. So here, for example, on this, I've got the two probe leads coming here on the standoff, and I've got the two battery clip leads going on to the other standoff, and that's all I've got. And then all these other leads basically are coming off the what would be the LEDs on here. I've just put loads of little leads off here, and all connected to the LEDs that are on the perf board, like so. So and also, of course, there's the adjustment here as well on the perf board, so that enables a little bit of adjustment, so that you can make sure you've got the the transitions are correct. You can just adjust this slightly. So that's the whole circuit really, and that's it completed, from soldering up to inserting inside its own little tin.